Hi friends, welcome back to my channel. So in last class we studied about centrifugal casting. Now we are going to study about die casting. Before entering into class, please subscribe my channel, like, share, comment. So if you have any doubts in any topic, please ask me in comment section. I will explain you. So now we are going to discuss about die casting. So die casting involves the preparation of components by injecting the molten metal at a high pressure into a die. So if you want to manufacture a type of cap, so for that we want to inject a molten material with a high pressure into this type of cavity. Then we get our required shape as this cap. So this is done by the die casting. So we inject the molten metal at high pressure. So for the required shape. So now it is closely related to the permanent mold casting because we are pressurizing the molten metal into the cavity because this very high pressure, because of very high pressure, the shape is very strength. So for that it is a permanent mold casting. So we call it as a permanent mold casting also. So this is a overall setup for the die casting. So there is one is movable half, another one is fixed half. So in between that we make our die cavity. So our die cavity connected is ejected place. So we can eject, that means we want to take the part to outside by the ejector plate. So the ejector place is connected to the movable half. So this is a fixed or stationary part. So it cannot move. So only moving half will be moves by the ejector pins. So here there is a guide pin. Because of this guide pin, it will guide so where to want to go. So next it has the cavity is fixed to the core pin. So this is a casting. So this is a shape we are going to casting. So this is a shape. So we have a runner and there is a piston arrangement. Because of this short sleeve, because of this arrangement, the molten metal is injected into the die cavity. So then we can manufacture this type of product. So because of the plunger, here there is a molten metal. So this molten metal is forced, is under high pressure and enters into the runner to the gate to the our required shape. So then we can get our required shape. So we want to wait for some time. It takes a solidification stage. This is a solidification stage. So we want to wait and then eject. So by moving half at the outside. So because of the ejector base connected ejector pins, then we want to take it out from the mold. Because of die casting, we can manufacture a complex shapes, narrow sections are easily produced because of we are injecting very high pressurized molten metal into the cavity. So because of high pressure, it will enter any section, any corners of the die cavity. We can manufacture a narrow types, complex shapes, irregular shapes we can manufacture. So the die castings are two types. One is hot chamber die casting, another one is cold chamber die casting. Now hot chamber process. That means in hot chamber process there has a gooseneck is used for pumping the molten metal into the die cavity. The gooseneck helps to pump the molten metal from and it enters into the mold cavity. So the gooseneck is made up of grey alloys or ductile iron. So and the plunger is a alloy cast. So we want to manufacture for the gooseneck by the grey alloys or ductile iron, and the plunger, that means piston arrangement, is made up of cast alloy cast. So in which the hydraulic operation, then it is a gooseneck is under the entry port. The plunger can develop the necessary pressure for forcing or entering into the die cavity via nozzle. That means here this is a diagram about the hot chamber process. So this is a gooseneck. See, this one is a gooseneck. So the gooseneck is it is made up of a grey alloy. So or then here is a holding furnace. because in holding furnace there is a molten metal, so it is very high heated molten metal, so there is a one opening gate, so in gooseneck. So because of this there is a plunger operation, there is a one hydraulic fluid reservoir. Because of hydraulic fluid reservoir, this reservoir helps to operate the plunger, and then it opening and closing the gooseneck. So when it is in downward motion, the gooseneck is closed. At that time, no entering the molten metal into the gooseneck. So when there is a plunger is in upper position, in this position there is a opening of molten metal enters into the gooseneck. This way it enters into the gooseneck, so it cannot move to the upper side because of it is it has no much pressure. For that the plunger moves downside and it pressurizes this molten metal and enters into the gooseneck. So it forcefully enters into the gooseneck and to the nozzle to the our die cavity. So it has a runner and sprue. This is a die cavity. We can manufacture this type of shapes. For that there is a nozzle. With this nozzle it enters the our die cavity. So this is a process. So hot chamber process, understood? So it is very important topic. I'm repeating one more time. So here there is a molten material. This molten metal is enters into the gooseneck when the plunger is upper position. That means the mechanism is in upper position. So at that time they enter the molten metal into the gooseneck. Because of this, it will, when the plunger moves downside, so this port is closed and the molten metal is pressurized and injected into the our die cavity. So via nozzle it enters into the die cavity, and then we can wait for sometimes for solidification, and we can afterwards we can eject. So first of all this position is come to the this position and will enters into this die cavity. That means the molten metal fills this entire cavity. Here there is a ejector plate. So because of the ejector plates, one is a movable part, one other one is fixed part. So this is a fixed part, this is a movable part. So this part is connected to the ejector pins. That means it can be movable, it can be take it outside by this ejector piece, and we can take the mold cavity our required shape by these ejector pins. Now this is a cold chamber process. So cold chamber process where we are using means for the in the hot chamber process is used for low melting temperatures. So the materials which are low melting temperature, alloys such as zinc, lead and tin are the materials we are going to manufacture components. So because their temperature melting is very low, so the gooseneck is always contacted to the molten material. The molten material is very heated, so because of this there is continuous contact with the gooseneck. There is a hot, very hot. For that at time it should not melt. If it melt means our process will go wrong. So for that low melting temperatures should be there, for that which we are going to manufacture product such as zinc, lead, tin. These type of materials only we are used to manufacture in hot chamber process. So the softer materials such as aluminum, brass and their high melting temperature. So these are high melting temperature to make it difficult to cast in hot chamber. So in hot chamber we cannot manufacture this type of aluminum, brass materials. So these type of materials is manufactured by the cold chamber. So because of gooseneck is continuous contact with the molten material. Okay, so in cold chamber process the molten metal is poured into the ladle. So there that means open the gooseneck. Now here we are pouring the molten metal into the ladle, that is in short chamber. So for the every shot the molten metal is enters into the cavity. So if we apply a pressure to the our molten material, that is a shot, is with that shot it enters into the die cavity and then we can get. So this is a setup. So this is a ladle, this is a shot, that means we want to add, this is a plunger or piston we call it. So this is a cavity, this is the shape we get. So this is a core. Here there is a ejector pins, so ejector die. So because of this ejector pins we can take the our required shape outside. So that it is a ladle. First of all we want to pour the molten metal from this ladle. Here this is a molten material. So when we enter into this, poured the molten metal into this ladle, then the plunger or piston will pressurize this molten material and will enters into this die cavity. So see here, the piston is applied to the molten materials, then the molten materials is enters into the entire die. So by applying pressure, entire die it enters. So this is next. So after that there is a fixed one and a movable one. So fixed one is at a fixed position only. Because of these ejector pins we can move the moving heart to side. So after that this is the arrangement how we are moving the moving plate. So this is we moved into two parts. This is movable part, we can take this as outside. So this is the total product. This is our required shape. This is our required shape. We injected, we ejected and we get our required shape. So please subscribe my channel.